Assalamu alaikum. Today we're going to start the mathematics for class 9. The book which we are going to follow would be the KP board book. That's Khyber Pakhtunkhwa textbook board Peshawar. So let's start. Okay, the first chapter in this book is matrices. So what are matrices? Matrices are a set of values enclosed in square brackets. So a set of values enclosed in square brackets. That's easy. Okay, for example, if we give an example, another matrix, not this one. For example, B is equal to 1, 0, 0, 1, the simplest one. This is a matrix. Now the numbers which are present inside these square brackets are called its elements. So 1 is its element, 0 is its element, and 0 and 1 are also its elements. So the necessary things for a matrix is these elements enclosed in square brackets with a name. So you should give a name to it, for example B, C, it can be any value of your choice. Okay, the next thing we're gonna learn about matrices, it's the order of matrix. Order of matrix is the number of rows into the number of columns. So it's quite easy, isn't it? Let me demonstrate it. For example, the rows, we know that rows are horizontal rows, they're horizontal, these numbers, for example 1 and 0, these are rows, and columns are vertical, so these are columns, and rows are horizontal. So columns, you can suggest 1 and 0 must be its columns, and the rows, as I told you, these 1 and 0. So we could write the order of this matrix is order of matrix B is the elements in the upper row. We count that the first row is 0, 1 and 0, sorry. So 1 and 0, there are two elements, 1 and 0. So 2, the number of rows, these are 2 rows. Look, 1 row and the second row. So 2 rows, and we have 2 columns. This column, oh, I got a bit messy here. Sorry, let me clean it a bit. One, zero, zero, one. So we have two rows, sorry. These are two rows and 2 columns. 1 and 2. So 2 columns and 2 rows. So the order of this matrix is 2 by 2. It's easy. So you should learn this concept, because you need this concept everywhere in this chapter. This is an important topic, the finding the order of a matrix. By the way, the question number 2 of exercise 1.1 is also based upon this one. Okay, so let me erase these. So let's go further with question number 1. Which of the following are square matrices and rectangular matrices? So, square matrices, as the name suggests, square is a figure with all 4 sides equal. All 4 sides equal. Whereas a rectangle has 2 pairs of equal sides. So this means the 2 sides are not equal. This is equal to this, and these are equal to this, and these all are equal. So square matrices means the number of rows should be equal to the number of columns. And rectangular matrices means the number of rows shouldn't be equal to the number of columns. Let's demonstrate this. The first question is, which of the following are square matrices and rectangular matrices? Part A says 2, 3, 0, and 5. So, is it square or rectangular matrices? It's quite easy. So let's find the order of this matrix. We know there are 2 rows, horizontal rows, and 2 columns. So this order of this matrix is 2 into 2. So the number of rows are equal. So 2 is equal to 2, isn't it? So this means this is a square matrix. So matrix A is a square matrix. So matrix A is a square matrix. Let's move on to the second question. Second question says 6, 3, -1, 1, 5, and 2. Let's find the order of this matrix. So order of matrix B is, let's find the rows. How many rows? 1 and 2. 2 rows. So 2 rows into columns 1, 2, and 3. So 2 into 3. And we know that 2 is not equal to 3. So it's easy. B is a rectangular matrix. Let's move on to the third question. Part C. Not the third question, part C, sorry. Part C, let's just move on with the order of it. So order of C is the number of rows into columns. 1 row, second row, and third row. So 3 rows in columns. 1, 2, and 3. So 3 columns. We know that 3 is equal to 3, so it is a square matrix. Part C is a square matrix. The next is part D, which has only one element. So many people get confused in this. They're like, oh, we don't have rows here, we don't have columns here. So don't worry. This is also a row and also a column. So it's 1 row and 1 column. So this is quite easy. Order of D is 1 into 1. 1 is equal to 1, and hence this is a square matrix. Sorry. Oh, why am I getting wrong with square spelling? S-Q-U-A-R-E. Square matrix. So this is a square matrix. Next part, E. E is -3 and 4. So -3 and 4. Order of E is 1 row. We don't have another, of course. So order of E is 1 row into columns 1 and 2. So 2 columns. 1 row and 2 columns. 1 is not equal to 2. So we know that this is a rectangular matrix. So this is a rectangular matrix. Move on to the F part, the last part of question number 1. That's E is equal to -1 and 7. Let's find the order of this matrix. F is equal to 2 rows, 1 and 2. So let's, oh sorry, you don't need to write these brackets here. So 2 rows and a single column. So 1 column. 2 is of course not equal to 1, and this is also a rectangular matrix. So with this, our first question reaches to an end. So the next question, question number 2, is list the order of the matrix. So order of the matrix. We know how to find the order of a matrix. The order of A is, first find the rows. We know that it's rows into columns. So it's rows into columns. So 1, 2, 2 horizontal rows, and 1, 2, and 3 rows. So 2 into 3, 2 into 3. So 2 by 3 is the order of this matrix. So A's matrix, order is 2 by 3. Next is part B, it's -4. So the number of rows is equal to the number of columns because there is 1 row and 1 column. So B is equal to 1 row and 1 column. Similarly, if we go to part C, so part C, the order of part C, matrix C is 1, then 2. So we have 2 rows here. So 2 rows, 1, 2, 3. So 3 columns. So 2 into 3 is the order of matrix C. Next is part D. Part D is 2, 1, 3, 2, and 4, 1. The order of this matrix is I don't need okay, so you don't need these brackets here. 1, 2, and 3 horizontal rows. So 3 horizontal rows into 1 and 2. So that's 2 columns. So 3 into 2 is the order of matrix D. Let's move on to the other part. That's part E. 3 and 2 are the elements of matrix E. So matrix E, the order of matrix E is 1 row and 1 and 2. So 1 row and 1, 2 columns. So 1 into 2. The order of matrix E is 1 into 2. Okay, so moving on to the next part F is it's quite a huge one. Let's count the rows first. So 1 row, it's a 2 and 3. So order of F is 3 rows and 1, 2, 3. 3 columns. So it's a 3 by 3 matrix. This is question number 2 to an end. Let's start the next question. Next question says, if matrix A is equal to this matrix, give the following elements. We need the given elements. So here they say that A12. We know that A is a number, so you should ignore A. So A is a number which is in, this is the address of A. So A is in, okay, you can take this as an address. So that's 1 and that's 2. So 1 means the row and 2 means the column. That's the same thing when we find that the order of the matrix. So the first one we take is a row. This is a row and this one is a column. So row and a column. So A is a number which is present in the first row and second column. So first row, this is the first row and second column, and this is the second column. So first row and second column, first element is 2. So A is a number which is equal to 2. This is 2. Let's move on to the second part, which says that A is a number which is present in the second column and second row and third column. So second row and third column. We move on here and here. We get a 0 here. So 0. So A is equal to 0. The next part 3 says A 3 2. So A is a number in the third column. The third column and row, sorry, that's the third row and second column. So it's 1. It's 1. So A32 is A is 1. Moving to part 4, it's A43, fourth row and third column. Fourth row, these are the rows, this is the fourth row and third column. So this and this, 6. A is equal to 6. Another part 5 is A is present in first row and third column. First row, this is the this is the first row and third column. First row and third column. So this is -4. Okay, 1 3 is -4. The last part is A33. Is present in the third column and third row. Third column and third row. That's 5, of course. So A is equal to 5. So you got these values here. This is more likely finding a location on a Google map. So this is the end of this question. Let's move on to the question number 4. Question number 4, quite easy, says that which of the following are equal? Matrix A is 2 5 1 3, matrix B is 2 5 4 3, and matrix C is 1 plus 1 3 plus 2 4 1 plus 2, and then D is 2 4 plus 1 1 and 3. So if we want to find the equality of two matrices, you just put these the two matrices, of course, in your mind and put these on each other. So if we take this, like for example, it's a matrix 2 5 1 and 3, and we want to find if it's equal to matrix B here. So what you do is put the matrix on this matrix. So the first element of B is 2, the second is 5, then here it's 4, and this is 3. So these are equal, these are equal, these are equal, but this is not equal. So this matrix A is not equal to matrix B. So I think you must have got the idea. Let's start the exercise. Okay, matrix A. Let's match matrix A and B. So matrix A and B are not equal, as we said. Let's find matrix A and C. So A is this and C is this. So first is here in A, it's 2 5 1 3. If we put this second matrix, that is matrix C, on the top of this, or maybe just add it, so it would be like, okay, first let's solve this. 1 plus 1 is 2, then 3 plus 2 is 5, this is 4, and 2 plus 1 is 3. So as we can see, this is equal to this is equal to this, sorry, this, okay. So this is equal to this. I mean, oh no, that's not equal to this, because 1 is not equal to 4 and 3 is not equal to 3 is of course equal to 3. So matrix A is not equal to C. Let's match it with these other matrix. Matrix D, matrix A. Here we get, let me erase these. So matrix A is 2, 5, 1, 3. Matrix D is 2, 4 plus 1, 5, 1 and 3. Oh, we get these equal. 1, 2 is equal to 2, 5 is equal to 5, 1 is equal to 1, and 3 is equal to 3. So we know that A is equal to D matrix. A is equal to D matrix. So if these both are equal, these both, let's match these two then. Let's match matrix B here. So matrix B is 2, 5, 4, 3. So matrix B, oh, I'm out of space here. So let's just compress it a bit. So matrix C is 1 plus 1 is 2, 3 plus 2 is 5, 4, and then 2 plus 1 is 3. We get equality here. 2 is equal to 2, 5 is equal to 5, 4 is equal to 4, and 3 is equal to 3. So we know that B is equal to D. So matrix A is equal to D and B is equal to D. Moving on to the next question. Next question says, if A is equal to this matrix and then B is equal to this matrix, what are the values of U, V, W when A and B are equal? So if these two are equal, then what are the values of U, V, W? So as you know, these places, if you put these both on top of each other, the value which will match would be equal to the other matrix. So if you put matrix B on the top of this, so at the place of 2 you will get V, at the place of -3 you will get -3, at the place of U you will get 5, and at the place of this 0 you'll get W. So let us write that. So the first place is 2 is equal to V, 2 is equal to V, then -3 is equal to -3, -3, then U is equal to 5, U is equal to 5, and 0 is equal to W. 0 is equal to W, and simply we get the answer here. So V is equal to 2, rearranging this, and of course this is all equal, I know, and U is equal to 5, and W is equal to 0. So the value of V to U is 5 and W is 0. Moving on to the next question, question number 6. It's a bit complex but easy. These are matrices with some equations. So matrix A, if we call this matrix A and this is B, so if matrix A and matrix B are equal, then find the values of A, B, C, and X, Y, and Z. So let's move on with the first equation. You just put the first matrix B on the second matrix, on the matrix A. You would get that this place is equal to this, and then similarly this is this equal to this, and this place is equal to this. I was just giving you an idea, so hope you know this. Let's start with this question. The first, let's make an equation of it. X plus 3, we got an equality sign here. Equality equals to this place. This is 0. So x plus 3 is equal to 0. Let's solve it on further. So subtracting 3 on both sides. So x plus 3 minus 3 is equal to 0 minus 3. So x is equal to minus 3. So the value of x, here we get minus 3. If we choose the second equations, that z plus 4, z plus 4 is equal to 6. So z plus 4 is equal to 6. Let's solve it on further. That's subtracting 4 from both sides. So z is equal to 6 minus 4. Z is equal to 6 minus 4, and z is equal to 2. So the value of z here is 2. Moving on to the next one is this 2y minus 7 equals 3y minus 2. So that's 2y minus 7 equals 3y minus 2. That's 3y minus 2. So rearranging this equation, we get that's 3y minus 2y is equal to minus 7 and then plus 2. So 3y minus 2y is y is equal to minus 7 plus 2 is minus 5. Here we get minus 5. So the value of y is minus 5. So x is minus 3, z is 2, and y is minus 5. Let's find the value of a's. So a minus 1, here is this is here, and which is equal to this place. So minus 3. A minus 1 is equal to minus 3. That's a minus 1 equals minus 3. Rearranging it, a is equal to minus 3 plus 1. A is equal to minus 3 plus 1 is of course minus 2. A is equal to minus 2. So a is equal to minus 2 is our answer. Next we go for b. B is, we get this equation here. B is equal to b minus 3 is equal to 2b plus 4. b minus 3 equals 2b plus 4. So 2b plus 4. Rearranging this equation, 2b minus b equals 4 that's minus 3 minus 4. So 2b minus b equals b equals minus 3 minus 4 minus 7. So b is equal to minus 7. Now the last value is finding the value of c. We get the variable c in this place. So 2c plus 2 equals 0. 2c plus 2 is equals 0. That's 2c plus 2 equals 0. So 2c, rearranging this, 2c equals minus 2, and then dividing on both sides, we get c equals minus 1. So if we conclude the answer, a is equal to minus 2, then b equals minus 7, so the c equals minus 1, x equals minus 3, y equals minus 5, and simply z equals 2. This is the answers for question number 6. Moving on to question number 7. Solve the following for A, B, C, and this is D. So A, B, C, D. We have equations here, so we must make equations from these. A plus B minus 1, 2. Let me write it with it. So A plus B equals minus 1. Second equation we can get, this is the first equation. Second is B plus 2C equals 4. This is the second equation. Third equation is 2. This is the equals this. So 2C plus D equals 8, which is the third equation. And the fourth equation is 2A minus D equals 0. So this is the fourth equation. Now what we need to do here is we need the values of A, B, C, D. So if we see, we get multiple variables in each equation. So this A and B and B and C and C and D and A and D. We can find these values individually from these equations. So what we need to do is actually, cancel some of these variables so we could get the value of a single variable, and then we put those values in these equation and get the values of others. So first, what we need to do is find common variables. In the first two equations, we get B as common. So, and the signs are equals, plus and plus. If we want to cancel these, we would subtract this equation 1 from 2. So subtracting 1 2 from 1. So 2 from 1, that's B plus 2C equals 4. So B plus 2C equals 4, and here we get A plus B minus is equals to minus 1. We don't have an A here, so we like the A outside, and we have a B, so B down here, and this is a plus, and nothing else here, equals minus 1. If we subtract these equations, we know that we'll change the sign. So here we have plus, it will become minus, minus, and plus. B and B cancel, and we are left with minus A, this plus 2C equals, so that's 4 plus 1 equals 5. We'll name this as the fifth equation. So this is the fifth equation. Now what we do is check out common variables in the third and fourth equation. So that's D and D. We can cancel this D because the signs are not equal, so we just add them. So that's 2C plus D equals 8, and then 2A, oh sorry, we won't write this here, 2A, that's 2A minus D equals 0. So these cancel, and we're left with plus 2A plus, we won't change the signs here, remember, 2C equals 8, because 8 plus 0 is 8. Now this is our sixth equations. So that's sixth equation. If we compare the 5 and the 6 equation, we get something in common. That's 2C here and 2C here. So, and the signs are equal, so we'd subtract both of these from each other. So now we'd subtract this equation number 6. That's 2A plus 2C equals 8 from equation number 5. So minus a plus 2c equals 5. So it's subtracting, so change the signs. These will cancel, and here we'd get is 3, 2 plus 2, and 2 plus 1 is 3a, which is equal to 3. So 3 divided by 3, and here we get a as 1. So if a is 1, now we'd put these values in the other equations to find the values of b, c, and d. So b, c, and d we'd get, okay, where are the equations? These are the equations I made. So the first we'd find b, so that's a plus b equals minus 1. So a plus b equals minus 1. We'd put this 1 as the value of a, so 1 plus b, which is equal to minus 1. B is equal to minus 1 plus 1, because we add this subtract 1 from both sides. B is minus 1 minus 1, which is minus 2. So b is minus 2. For the third value, I mean c, we take this equation, no, sorry, not this equation, this last one, 2a minus d. So this 2a minus d equals 0. So 2a minus d equals 0. So the value of a is, we know, 1, and minus d, which is equal to 0. So 2 minus d equals 0, and minus d equals, this is minus, subtract from it both sides, so minus 2. We get this minus to the cancel on both sides, so d is equal to 2. So d is 2, a is 1, and b is minus 2. The value we are left with is c. So putting the value of d in equation number 3, 2c plus d equals 8. So 2c plus d equals 8. Putting the value of d in this equation, so this is 2c plus 2 equals 8. So 2c, subtracting 2 from both sides, 8 minus 2, and this is 2c equals 6, and then divide 2 on both sides, and divide 2 on both sides, we get 3 here. So c equals 3. So with this question number 7, we reached the end of this exercise 1.1. Be sure to watch my other videos, and don't forget to subscribe my YouTube channel, and also click that bell icon so you could get the notifications of all the new lessons I will upload.